All right, welcome to screencast number 1 from Module 13. This is going to be Lesson 1, where we're using graphs and properties to solve equations with exponents. So Module 12, and actually even Module 11, we started dealing with exponents. Module 12, we did exponential functions, and Module 13 will kind of be an extension of that. So there's going to be more things related to exponential functions. All right. It says that in previous lessons, variables have been raised to rational exponents, and you've seen how to simplify and solve equations containing these expressions. How do you solve an equation with a rational number raised to a variable? In certain cases, this is not a difficult task. If 2 to the x equals 4, then it's fairly easy to see that the x is 2, since 2 squared is 4. In other cases, like 3 times 2 to the x equals 96, well, where would you begin in order to figure out that x? Well, that's what we're going to do, so let's find out. So we're going to move into this first example, and it's kind of just showing you a process for how you would eventually figure out the answer to what is the x. Okay? All right, so it says solve for 3 times 2 to the x equals 96. Solve it for x. First thing we're going to do is let our function f of x equals 3 times 2 to the x. Let's complete this particular table, and then we're going to use the table of values to graph that function. Okay, so let's do that. So I'm going to pause, and you pause also, fill in the table, and then graph, and then hit play and see if you get what I get. Okay, so they did the first one. If x is 1, so 3 times 2 to the first power, that's just 3 times 2 is 6. Then the next 3 times 2 to the second power would give you 12. 3 times 2 to the third, because 2 times 2 times 2 is 8, and then 8 times 3 is 24. 3 times 2 to the fourth is 48. 3 times 2 to the fifth is 96. 3 times 2 to the sixth is 192. 3 times 2 to the seventh is 384. And if you notice on here, I can't even plot these two because the graph doesn't extend that high. Okay. I'm not ready to discuss it, but I do want you to notice that particular point. Okay. Just because, it's interesting. We're involving 96 up here, and we've got a 96 down here, but I'm really not ready to do anything else with that. So just kind of just make that observation. Okay, then we're going to do a second equation. We're just going to say that that equation is equal to 96. That would be like saying y equals 96. Okay? Is there an x? No, that means there's no slope, which means that this is a horizontal line at a y value of 96. So when x is 2, there's no x value over here. So when x is 2, the function's value is 96. When x is 3, the function value is 96. When x is 4, the function's value is 96, etc., etc. So fill in the table. Okay. If it makes you feel better so that you understand really what's going on, that's what you're doing. And every time you put in, like, the function value when x is 1 is 96. The function value when x is 2, 0 times 2 is 0 plus 96, etc. So it keeps the same value regardless. All right, so let's graph that. Okay, and it shouldn't be hard to see that the value or the graph of a function that has no slope creates a horizontal line. So there's your horizontal line at y equals 96, or g of x is equal to 96. Okay, so if I wanted to put both of these on the same graph, then where are the graphs going to intersect? All right, well, let's go back up here. I think it's easier to just take the second graph and put it up here rather than the other way around. So that second graph, and I'll do a red line this time. Remember, g of x, oops, okay, that's kind of sloppy. It's supposed to be right there on that line. G of x equals 96, so there's that line. So where are the two graphs intersecting? They are intersecting at an x value of 5 and a y value of 96. And I'll explain why you should care about that in just a second. All right. The graph intersects at 5, 96. And this means that f of x equals 96 when x is 5. Okay, so let's continue on the next page. All right, look at number 1. It says discussion. Consider the function. They're now talking about a third function. Let's say that we had a function h of x is equal to negative 96. Well, that's this line down here, way down below the x-axis. Here is our g of x from the previous page. Okay, so f of x, our original equation, looks like this and intersects g of x at 5, 96, right? Well, if they say, well, where does it intersect h of x? Well, h of x is way down here. It doesn't intersect it at all. And the reason why it won't ever intersect it is because whatever value you put in there for x, you're going to generate a y value that's positive. So you're never going to have anything graphed down here in the negative y territory because of the way this particular function is structured. Okay, so let's construct a little answer to that. Okay, so in this particular case, if they're talking about h of x is equal to negative 96, which is down here, this line, then f of x and h of x are never going to intersect. And again, that's just simply because the way that this is written, we're always going to have a positive y value, regardless of what x value we put in there. Okay? All right, number 2 says to divide both sides of the equation, 3 times 2 to the x power equals 96. Divide it by 3 and utilize the same method as in Explore number 1 to graph each side of the equation as a function. Okay, so hang on. Okay, so they're saying divide both sides of the equation by 3. Well, 3 divided by 3 over here gives you 1. And so on that side of the equation, you just wind up with 2 to the x power. And then 96 divided by 3 is 32. Okay, utilize the same method as in Explore number 1. Okay, so I am actually going to reuse the same graphs since they didn't give me any graph paper here. I'm going to go back to right here, and I think I'll use blue this time. We now have 2 to the x and I'm going to do some values to the x, oops, 2 to the x and x. Okay, I'm back on the original page. What I've done is I have graphed that second line. Remember what we did is we divided both of these sides by 3, so now we have 2 to the x is equal to 32. So I have my set of x's and then my y values, remember, because your f of x is equal to 2 to the x. So when x is 0, your f of x or your y value is 1. When x is 1, f of x is 2. When x is 2, etc., etc. Okay, and then I took these and I graphed them. And that's this line right here. It may be hard to tell the purple and the blue. Okay. Okay. This time the intersection point, if I also divide that second equation, g of x equals 96, if I also divide it by 3, then your intersection point is here at 5, 32. Now, really what I want you to do is, number one, not freak out about, oh my God, she's got all these lines on here. But your x value is 5 regardless of which way I did it. Before I divided it by 3, after I divided it by 3. Okay? So, the point of intersection would be at 5, 32. So it's not the same point of intersection. It's not the same answer, even though the x value is the same. Can this be done? Yes. Well, it can be done because the equations are equivalent, because one equation is just a multiple of the other. So this equation is equivalent to 3 times 2 to the x equals 96, because I get this equation when I just simply divide the original one by 3. Okay, so what I want you to see is a little bit of thinking will tell you that 2 times 2 times 2 times 2 times 2 gives you 32. So that x that you're missing is 5, which makes sense because that was also the intersection point in our solution.